Hello students. In trick number 180, today we are going to start a very important topic of arithmetic progression, which is very important for class 10 students who are going to appear in board exams, and also for people who are trying to clear competitive exams involving all numerical ability portion. So for understanding what an arithmetic progression is, let me write a series of number -1, 3, 7 by 2, root 2, 5 by 2 and so on, and another series of numbers, say 3, 7, 11, 15, 19 and so on. Now both of these are actually series of numbers. Some numbers are written one after the other, but in the first case I have written them in a random order where you cannot judge which number is going to come after 5 by 2. Whereas in the second series 3, 7, 11, 15, 19, if you look carefully, I am adding 4 to the previous term to obtain the next term. So 3 plus 4 is 7, 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19 and so on. So if I ask you what will come after 19, you will be able to tell that very easily. So in this series, the progress of this series of numbers is not known, whereas here the progress is known. You can tell any number of terms of this series just by looking at these numbers. So any series whose progress is known is called a progression. Now this is what we needed to understand, that progression is actually a series of numbers whose progress can be adjusted by just looking at some of the initial terms of that series. Now these progressions find wide applicability in numerical aptitude tests where the questions based on series of numbers are given. These progressions are classified into many types, and one of the types is the arithmetic progression. Now, there are obviously many other types of arithmetic progressions also which are taught at higher classes, but in this series of videos, we will be concentrating on arithmetic progression only. So, let us understand what is the arithmetic progression. Basically, a arithmetic progression is a series of real numbers. They have the difference between consecutive terms as constant. Now see, the difference between consecutive terms is constant. Now see, if I subtract the second term and the first term, I get 7 minus 3, 4. If I subtract 11 minus 7, I get 4. If I subtract 15 minus 11, I get 4. If I subtract 19 minus 15, I get 4. So this difference between the consecutive terms should be constant. Then we call that series or that progression as arithmetic progression. So let us take one more example. Say we have -6, -1, 4, 9 and so on. Now let us check whether this is an arithmetic progression or not. See, if I subtract -1 and -6, I get 5. So this difference is 5. If I subtract 4 and -1, I get again 5. If I subtract 9 and 4, obviously I get 5. So this difference between consecutive terms is same. So this series of numbers also forms an arithmetic progression. Now, after having understood what an arithmetic progression is, we need to understand what is the terminology associated with this arithmetic progression. Now, for this, let us concentrate on a single example and understand the terms. Say, I will take the first example. Now, this is an arithmetic progression. The first term of an arithmetic progression is normally denoted by the alphabet small a, and in this case the value of a is 3. So the first variable is a. The second variable is the common difference I have told you just now, which is denoted by d and which is obtained by subtracting the second term from second and the first term, or the third and the second, fourth and the third, and so on. You can take any two consecutive terms and subtract the next term with the previous term. So 7 minus 3, this is 4. So a is 3 and d is 4. The number of terms in any arithmetic progression is denoted by n, small n. So small n denotes the number of terms. Any particular term is denoted by a and subscript n. So a n. A stands for term and n stands for term number. So if I have an example of term number 3, then first, second, third, term number 3 is 11. So n is the term number and 11 is the value of that particular term. And finally we have sum of first n terms, which is denoted by S stands for sum and subscript n stands for number of terms. So if I take first 5 terms of this arithmetic progression and try to find the sum of these 5 terms, then it will be denoted by S5, and it will mean the sum of first 5 terms of this AP. So these are the 5 things we need to understand. A is the first term, D is the common difference, N is the number of terms, An is the particular term value, and Sn is the sum of n terms. All concepts of AP revolve around only these 5 variables, and if you have understanding of these 5 variables, then we can very easily solve questions related to this. Now, what are the basic formulas which are involved in this important topic? Now, for finding any general term, that general term is denoted by An, and the formula for finding An is A plus n minus 1 into D. Just observe in this formula that if you are trying to find, suppose I have one example wherein I have to find the value of term number 8. Now see, this is the first term, A is 3, and this is the common difference, D is 4, and for this series I need to find the 8th term. So the formula for 8th term will be A is 3 plus n minus 1, n I am taking 8 terms, so the value of n will be 8. So 8 minus 1 is 7, and D is 4, so the value will come out to be 31. Likewise, you can find any term of this AP. Say we have term number 76. This will be A plus 76 minus 1 is 75 into D. D is 4. So 3 plus 300, which is 303. So you see, if we know the first term and the common difference, we can find any term of a given arithmetic progression. Then come to sum of first n terms. Now if we want to add a particular number of terms of this arithmetic progression, the formula which we need to apply is n by 2 2a plus n minus 1 into d, or you can reduce this formula and write it as n by 2. If I take 1a out of this, I will be left with a plus n minus 1 into d, and a plus n minus 1 into d is this formula an, so I can write it as a plus an also. In class 10th arithmetic progression chapter, you have only these three formulas, or rather we have only two concepts. One is the general term and one is the sum of first n terms. In our subsequent videos on arithmetic progression, we will solve a variety of questions based on these two formulas and how knowledge of these five can enable us to solve any particular kind of arithmetic progression question. So keep viewing the subsequent videos, and from trick number 81 we will be solving a number of questions related to this important topic. So till then, keep viewing the channel and share and subscribe the videos if you like it.